NoOps. You guys like NoOps? Like hell no. Go back to Portland. I will later. Don't worry, I will later. All right, let me get this set up here. All right, so this is going to be more of a kind of a practical talk. I will talk about a bit of tools and the way we think about things. But I want to start with this idea of NoOps, okay? So my background, I do identify myself as a sysadmin. You know, that's how I started my career. Full-time developer the last couple of years, but I still think in the ops-centric way. But when I hear the term NoOps, I get excited. Mainly because I think it's probably the proper goal, depending on how you look at servicing an organization or being the operations person in a company that delivers software, okay? Bear with me, I'm gonna try to prove this out. So in 2011, when this article was posted, a lot of people got in a tizzy about this idea of NoOps. Especially at the thick of it was the DevOps movement, right? Ideally, developers and operations people work together to deliver software or provide business value. And in this particular article is like, that's just not enough. That is too small of a stepping stone to where we actually need to be, okay? So a lot of people I don't think actually read the article, right? Some people just saw the name and said, oh, NoOps means no operations, okay? How many people had that idea when they heard NoOps for the first time, all right? So I'm going to step through the three kind of key points from this article, and you just clap if you agree with it. You can just boo loudly if you disagree with it. Okay? Make it interactive. All right? So the first one is improve the process of deploying applications. Not VMs, but also release management. You guys seem to like NoOps so far. Developers never have to speak to operations. This is a funny one. How many people have like internet access at home? What if you had to call your ISP before you could get online? It'd be absolutely terrible. You would say this service sucks, right? You would look for a new ISP ASAP. Because you would ask yourself, there is no reason why I need to call someone to get online. And if there is trouble, there should be an automated system for me to at least do the initial diagnostics without talking to anyone. The last thing you want to do is call anyone at your ISP to sort out your internet issues. If they don't have anything that's automated or a status page, you would say it's unacceptable. Why am I having to talk to you to solve such a simple problem? But for most companies, that's ops. If you want to do something mildly complicated, you actually have to talk to someone. So in our normal lives, that would be unacceptable. But at work, it's status quo. We used to be okay with that. Remember when people used to say this? I'm trying to automate myself out of a job. Anyone had that goal before? Yeah. So if you were successful, no one would be talking to you, right? Like, why would they talk to you if you've actually reached this goal? If you've actually made it there, there will be no need to reach out to you. It should be fully automated, okay? Remember this one? When people ask you for too much. This was a thing, and this happened to some people actually. Unfortunately, some people are no longer employed in the tech industry because they were replaced by a shell script, and you probably wrote it. So what I'm going to do is kind of talk about NoOps versus DevOps, okay? We have these two trains of thoughts. One side, I don't think there's anything wrong with two groups of people working together. But I do think there's something wrong when two groups of people have to work together to do something that can be totally automated, okay? So what I'm going to do is attempt to show something from the DevOps point of view, and then something from what people will consider the NoOps point of view, all right? Let's start with DevOps, okay? So DevOps, you get really excited about like new tools to automate things. We always say it's not about the tools, but more than likely you're using some tool to kind of implement the ideas and provide a little bit of value. How many people have used something like Kubernetes? You're a very happy user of Kubernetes. I like this guy. How many people have used like a scheduler, something to automate like the deployments? So not very many people. All right, so the quickest way I can show you what a scheduler is, we're going to play Tetris, okay? So Tetris is going to allow us to get a really quick example of what these schedulers aim to do. How many of you have like automated deployments? Click one quick button, fully automated. Pretty badass. This is like the goal, okay? So I'm going to show you what that world looks like. So when things are fully automated, it's pretty badass. But there's slightly a problem there, okay? When it's fully automated, you click one button, and you walk away. It's fully automated, though. To the left and right, that's like CPU and memory, right? You're just wasting resources. How many people complain about their cloud bill being too high? This is why. Just automated deployments don't get you there, right? There's a better way of thinking about these things, okay? So when you're using kind of these schedulers, and most people didn't raise their hand, which is odd, because most people have a multi-core machine. And on that multi-core machine, when you launch a process, something has to schedule what core it runs on. So you're using one every day. It's just transparent to you, so you don't believe it's there, right? It just works. So when you're using one of these schedulers, their goal is to take your workloads. They all come in different shapes and sizes, and most of them practice this idea of bin packing. So the goal here is as our workloads come in, we spread them out onto our servers in a way that leaves room for larger workloads. So this algorithm that I'm currently doing is called bin packing. Very common. And the reason why you want to do this is because you want to increase resource utilization on your servers, okay? Now I know a lot of you are like, man, he's totally going to lose Tetris in the middle of his topic. Like, no, I won't. And the nice thing about these schedulers, when the big workload comes out, maybe it's a big batch job, it leaves room in the cluster to run that particular batch job. So you end up something like this. And the nice thing about these resource schedulers is when the work is done, they reclaim the resources so that way you can start again. This is how you get your utilization high. So not just automated deployments, but you also want to think about resource utilization. Now these things also work in greenfield or brownfield environments. So how many of you guys have current enterprise, maybe production applications? Some legacy going on? Don't look shameful about legacy, man. The nice thing about people with legacy, like when I travel and you file out an expense report, companies that make money can actually reimburse you. Startups are just like we don't have it, right? We don't have any users, trying to find a market fit. So when you're in brownfield, the world looks a little bit like this. You know, you have an existing workload, and you put these tools on top of your existing clusters, and over time, they will start to kind of defrag your cluster by utilizing resources. So as you start to migrate things over, and some people would say containers are kind of the core of this. I think that's kind of an implementation detail. But the goal is to start moving workloads into one of these tools so they can manage the resources, all right? Now, if you're in enterprise, things are a little bit more challenging. I'm going to be a little bit upfront and recognize that there are challenges to the enterprise. So a lot of times in the enterprise, everything's written in Java, okay? You got Oracle database. All right, so it gets a little challenging, all right? So in that world, to be honest, there's nothing we can do to help you. So it does not solve all problems, okay? So that's what these resource schedulers look like. So in DevOps world, when we see these kind of tools, we're like, all right, I want to start using them. So the way these tools work is they're declarative, kind of like infrastructure as a code. So what we want to do here is we're going to deploy, let's say, our Nginx app, right? So here's a declaration that I want 3 copies of Nginx in my cluster. The goal is that I'll use the command line tool, and I'll push this to my cluster. Let me set the version that I want. I'm going to use an older version of Nginx to start. So I'm going to come down here, and this is kind of what we do in the DevOps world. We'll learn a tool, right? And then I'm going to push this workload up to my cluster, Nginx. And the goal that if this works, I should get 3 copies of Nginx running. So this is badass, right? You're like, this tool will help us do automated deployments, okay? And there's other things you can do as well. I can hit this to make sure that it's working. Let's go and visit this front end here, just make sure that we can pull the website up. So we do this and we're like, okay, this is the tool we want to use. And a lot of times, this is kind of where we stop. The goal is now we're going to teach everyone in the organization how to use this tool, right? We're going to call it DevOps. I'm going to teach ops people how to use our tool set, and we'll collaborate. Now, sure, we may edit these files and have some delivery process, or we push them up to a remote repository. So here, if I wanted to do an upgrade, here, let's do something like this. Control R, while true. Let's say I have this version running, and if we wanted to do an upgrade, I can teach my ops team how to, or my developer team, how to either edit these files, push them up some change management process. So let's apply this. Maybe we put this in CI/CD. But the problem that we're doing here is that we're leaking this abstraction to the world. So if we ever want to move on from this tool to another tool, everyone's going to be stuck, knowing that this is the tool that they use for everything. It's going to be hard to replace these things. And plus, we got to go through another training exercise as we do it. But the tool does add a lot of value. So look at that. We were able just to change one file and roll out all of our applications. So most people want this, and then they deploy it company-wide, and they go on this mission to start training everyone, right? So now you have yet another tool to learn. And this would be, someone would say, this is good DevOps, right? Multiple people in an organization are being able to do operational tasks, maybe using some tools that provide a bit of abstraction. All right, so let's think about this from a NoOps point of view. So if someone came to you and said, hey, I want to do a deployment, and you say, oh, we're using Kubernetes, get the command line tool installed, or maybe you're doing some chat ops thing, but you're exposing them to Kubernetes directly. So in the NoOps world, we want people not to understand any of this stuff. We want to give them an interface. So I'm going to delete this and think about this from another angle. So let's say you have a company where you want people to do a deployment, but use an interface that they understand. They don't need to know anything about Kubernetes, and they don't need to interact with us in operations. So here, I'm going to do something that's familiar to like business folks, okay? So one thing I could do is I'm going to use a tool. Let's see if you guys recognize this tool. You guys use this tool? You know about Jira? There's always like one or two people at a company that like the Jira masters, right? Custom fields, custom workflows. Who here is that person? You're that person? I admire you. So Jira is like the enterprise interface. This is as enterprise as it gets, okay? So let's connect to Jira and see how the NoOps process could flow, okay? So most companies, for compliance reasons or maybe just for workflow and permissions, you usually have some process where someone can make a request for something to happen. And there's nothing wrong with this. Even in the continuous delivery world, you may have someone that has rules or policies before something can be released. So here's the holy grail for the enterprise, the ticket. How many people work from a ticket queue? Yeah, this is like the holy grail for a lot of people. So what happens is I want to do a deployment, and I can name that deployment Nginx here. I can give it one of those image IDs. Let's start with Nginx 1.10.1 like we had before. I can give it 3 copies. I can expose it to the internet, and then I'll say deploy ASAP. You always notice that all deployments are emergency. No one has like a request that's not right now. So we'll call it an emergency. So we go to this deployment, and typically, ideally, anyone that's doing the DevOps should be able to work this ticket, okay? Now, in the NoOps world, what we would like is to be able to assign this some approval process, whoever has to approve it, and we're going to assign it to the DevOps Ninja. Anyone go by that title? If you do, you don't have to speak up, but you should change it immediately. It is not cool on a business card, I promise you. If you have this on a job posting, this is why you're having trouble finding people. No one wants to be a ninja unless they're a martial artist, okay? So what I'm going to do here is I'm going to save this and assign it to the DevOps Ninja. Now, the nice thing about this is that the user of this particular system is using something that they're familiar with, right? They're giving you enough information to get the deployment done. No one's talking about Kubernetes or any tools like that. So what we want here is to figure out how can we ease the transition between the request and things actually happening. Anything in between is just friction. Anything you ask people to do to get to the end state is friction, and most people would say it's unnecessary. So how do we make this unnecessary? So one thing I'm going to do is I'm going to possibly build a tool, and that tool is going to be called the Jira Deployment controller, okay? What I want to do with this thing is I want to have it connect to Jira and look for any issues that need to be done. And if it's just a simple deployment, that should just happen automatically, right? So I'm going to deploy this Jira deployment controller, and the goal is that it can read these custom fields that we just filled out and make things happen on our tool of choice, right? Whether it's Kubernetes or Puppet or whatever you're using, we can hide some of that stuff. So what I'm going to do now is just deploy my controller. And Jira deployment controller, okay? So once this is deployed, kubectl git pods dash namespace equals Jira. And what we can do now is look at the log for this thing. So I just want to see what this thing is actually doing. And we'll look at the deployment controller. All right. So this thing is going through and processing a particular issue. Now let's refresh here. Oh, it failed. This is bad. This is not good, is it? Why do we think it failed? Anyone have an idea? Because I need some help. All right, let me create a new ticket here. Let's see. Let's do more. That's what you do. You just delete the ticket and say, we don't remember that. Not our fault. Let's do Nginx. Let's pick an image here. And let's make sure that we're clean. Let's leave that running. kubectl git pods. All right, so let's deploy this. We want 3 copies. This is emergency for real this time. All right, let's see if we can make this work. All right, so let's assign it to this DevOps Ninja person. All right, hit check. This is really bad if this doesn't work, man. Whoo! Let's see. Yes. It's okay to impress yourself. All right, so we got this thing deployed. And let's look at the version that's currently running. All right, so now that this thing is deployed, we see we have this version. And now the user would like to have an upgrade, okay? So ideally, they could create a new ticket, or they could edit this ticket if they want. Let's do an edit here. And let's go to Nginx 11, okay? And then we'll hit update. And then what we want to do is put it back to do, because they would like us to do this work. And we'll watch our logs from our controller, and we're seeing at some second or some moment, this thing should pick up the new request from the user. And we see that we have 11. It should be deployed. We'll see here from our logs that now the user has a new version. And notice that the user, from request to what's actually happening in production, there is no perceived interaction with the operations team. And sometimes they'll say, yeah, we don't have an ops team, right? And if you get to that point where they believe that there is no operations team because they can do all of their work through a common interface, all the policy and stuff from Jira is reused in the situation, I think you're winning. And a lot of times, if this is what people consider as NoOps, then that's fine, right? You will always need an ops team, right? We're not saying you're going to get rid of the ops team. It's just that we can hide behind these interfaces that don't leak and have to train everyone how to use every tool, because we change them every 2-3 years, something new comes out. So we can put them behind these interfaces, and we want to move to another tool. No one needs to know the difference because it's hidden behind this, all right? So that would be, to me, the NoOps way of thinking about these things. So the way I like to think about NoOps is just operations with better UX, okay? The UX is so good that people believe that you're practicing NoOps, okay? Now, I'm going to give you another concrete use case about how you think about these things when you're given a new opportunity. And I think in the future, as we move towards a world where there'll be less interaction with ops, and we start to think about how these technology people at a company work together regardless of role, you can think about this idea of managing certs, okay? How many people had to manage TLS certificates before? All right? So here's the process that I had to do in the past. So you purchase a TLS certificate, okay? This is pretty standard quote. You use a configuration management tool to push out those certificates, right? So you need to know where those certificates are going to land. And I think this is where using tools that are too low level put us in a situation where we have to have tons of interaction. Which servers are you going to push them to, right? Who has access to push the certs to a server? And these things really define how our culture works because the tools will dictate how our processes are set up. So we need a little bit better abstraction. I think this is something in ops that we can do a better job of, not just turning the knobs of tools that are given to us or that we buy, but actually thinking about better abstractions so we can actually change the way we work. The next thing we do is we write Nagios checks to monitor the cert from expiring, right? This is what a lot of people do. Or if you don't have a cert, a lot of you are like, wow, you should write checks to check that. Usually your customer will check that and be like, hey, your cert's expired, right? I know some of you are looking around, it's like, you know that fire drill. And it happens to us, okay? So we have to start thinking about a better way of dealing with things like this. And let's talk about the upgrade process. You know, in the upgrade process, you renew that certificate, so maybe you go and pay some money and you renew it. And then, of course, you push it back out. You need to know what servers and keep track of it. And then we have this idea of restarting the application. Is this still like the status quo? Like you want to change configuration of search, you have to restart the app? And this dictates how our tools are built. Do this, then do that, then restart the app, right? A lot of people say the tools don't matter. I think they do, and they influence how you actually work. So to me, and I look at this problem, I'm saying, how do we solve this problem in a way where we can eliminate a lot of these things? It's not just good enough to automate this process, right? We want to make some of these steps just flat out go away. And we can actually do that, right? It's not about automation all the time. We need to figure out why these steps are here in the first place. So we can do better. I think we have to do better because actually most ops teams are now in competition. You're in competition with another ops team. Some people call it the cloud. Some people call it outsourcing or consultancy comes in. You are definitely in competition, right? I knew a lot of people that used to manage the ERP systems on site, SAP, and people said, screw that, Salesforce. They don't even tell you. It's like, hey, no one's asked for an upgrade in like 10 years on this thing because the whole company moved to Salesforce. You're totally in competition whether you know it or not. So now that you're in competition with other people willing to do your job better. These are ops people. These are peers in the industry willing to do your job better than you can. So you have to step up your game, and this is serious. A lot of people are like, it's not the case. It's totally the case. So when I think about this process, the first thing I'm going to ask myself, regardless of your role, ops or developer, why am I restarting the application? That makes zero sense that we're going to build tools that understand how to restart your app in order because we've changed some configuration file. Unacceptable. So we think about the problem. So let's turn our focus to the app. This is the thing that we're all responsible for delivering. So when I look at the application, this is a little bit of Golang, a small snippet. Most web servers have something like this, where the app says, hey, I'm going to read these two files. This is my key and my certificate, and I'm going to serve these files for the life of the process. And if you want to change that, you get to restart the process once you update those files, right? And ops is going to do that. That's what you do. I don't have to handle that in my app. But even if you're in ops, we can solve this problem. We can write code too. Nothing's stopping us from doing a pull request to the company's repository to fix a problem like this instead of scripting around it, okay? So what we can do is go to the application that is suffering from lack of operational excellence and make it better, right? So here's a little snippet where I'm replacing the default implementation with a custom function that will read the certificate on demand. Now, this is going to save me from doing a whole bunch of dependency order management. I can restart this application. I can refresh the certificates. So that's a piece of code that we're highlighting here. So the next thing I want to do is, I'm a sysadmin. I know that I can register hooks with the kernel to watch the two files that I care about. Right, this is old school Unix stuff here. I can just do iNotify. And whenever those two files change, my app will be notified. Sweet. All I have to do is just update the bits on disk. Once the bits are updated on disk, I can watch for those changes. So the minute those bits on disk change, I'll just reload them if they're valid certificates, and then swap out the in-memory representation of those certificates so the next TLS handshake gets a new cert. No one has to restart anything, okay? So that sets the foundation for getting rid of some of this stuff, right? And also, renewing a TLS cert. Like, there are much better tools if you're paying attention. How many people have heard of Let's Encrypt? Good, you should know about these things. Part of our job as professionals is we need to stay up to date on better ways of doing things. That doesn't mean we go and change everything, but we should know that they exist and know why we're not using them, right? That's part of the job, okay? Don't ignore this stuff. So things like Let's Encrypt will give us a new protocol for interacting and fetching short-lived certificates and automatically renewing them. So given that, we can actually improve the process on even how we purchase and manage certificates, okay? So what I'm going to do is move the logic of where certificates go closer to the application and the tool responsible for managing the application, right? So I want to start thinking about less scripting around the app, but using something where I express all type dependencies together. And then to renew, we saw Let's Encrypt, and I want to build something like this. So now as a user, I'm going to build what will feel like a product, not a script, not something ad hoc, not a one-off. I'm actually going to design a product for my organization, okay? I don't need the vendor to ship the thing to me. I can write code as well. And a little bit of glue that I want is I'm thinking about that user interface, whether it's a Jira front end or some object on disk, but I want to have some meaning to how you request and get a cert, okay? And then that interface all the way down to the application. So in this case, I'm going to build a tool called the Certificate Manager that will interact and look at user request, get a cert, validate the certificate, and update the application while it's running. And remember, I wrote the other code, so when I update the certs on disk, it will automatically have the app reload, okay? So what we want to do is go through and see how this works, right? And we're going to wrap up with that. So what I want to do now is we're going to start with this tool. So we saw here, stop this. So what we're going to do is try to make this work. So I'm going to delete this because we don't need it anymore. All right, so we're going to see if we can actually make this work. Now I'm interacting with DNS here, so this is a bit dangerous. DNS and live demos is not the smartest thing to do, but we got to do it live. All right, so this tool we've been using, Kubernetes, it has all these object types, pods, deployments, and services. But I want to also have an interface for certificates. Now those things don't exist in Kubernetes by default, so we have to create them. So luckily our tool supports extensions. So what I'm going to do is add a new object type, because when I'm doing my design for my new tool/product, I'm thinking about that user interface. But what I want is a schema defining the contract between the developer, the users, and the infrastructure. This part is key. Normally when you're writing a script, you don't really think about the contract. You just solve the problem. You don't really think about, hey, what are the inputs and what do you get on the outside? That little step makes your infrastructure way more robust. So what I'm going to do is create this extension, and now I'll be able to create certificate objects, okay? The next thing I want to do is launch my certificate manager tool. So I have a deployment, so I'm going to deploy this side by side in the tool of choice that I'm using. This is going to be really straightforward. This tool is basically going to talk to the staging API for Let's Encrypt, and it's going to request a certificate based on the objects that I create, all right? So we'll launch this thing. Let's make sure I have all of his dependencies. It also needs a volume. So gcloud compute disk list, make sure that I actually have my volume. I do, so this is what I want. Now what I want to do is launch this application, -f, deployments, kube cert manager. All right, so this thing should be up and running now. So we'll just look at its logs while it's processing in the background. And then we're going to deploy our application. All right, so this thing is going to take a moment to spin up, and while that's happening, we're going to deploy our example application so we can see how this all fits together. So we have an example application called TLS apps. It's pretty straightforward. What this does is it just reads certificates from this path on disk, and it can actually retrieve, Kubernetes will put those files on disk and make them available under this etc TLS directory, so the app can just mount them up. And we're going to start by running 3 copies of this app. So kubectl create -f deployments TLS app. All right, so kubectl get pods. All right, so those 3 containers are creating. I hope they create. They should create, or this would be bad. Live demos, man. This needs to work, doesn't it? All right, kubectl. What am I doing? Get nodes. We look good here. Docker Hub could be down. This would be bad. All right, so debugging time. Okay, that looks good. All right, so my guess is things are a bit slow. All right, so while that's coming up, let's look at the logs for our cert manager. All right, kubectl logs. And then we're going to see how this thing sits online, waiting for users to give us input. All right, so this thing now is waiting for certificate objects in order to provision a certificate for us. All right, now the last thing we want is this app to come up. Man, what is it doing? I need help, folks. Are you guys not praying to the demo gods for me? Ooh, I know what's wrong. Yes. All right, so the secret that this thing needs is not there, so Kubernetes is doing the right thing and saying, I can't do that. There are no certs in place. Some people on the edge of their seats like, dude, he's going to fail. I know it. But I must overcome. So let's do this. Create secret TLS. So I need to put the certs in place. Okay, once I put the certificates in place, I can actually launch the app that consumes the certificates. All right, let's see if that works. Because I was pretty confident in knowing that that was a problem. Yes. If you've never done ops before, this is what it's like, actually. You're on call, you just got to be confident. Do you know what's wrong? Hell yeah, I know what's wrong. So why are you on mute on the bridge? I just need time to think, okay? That's what you do, okay? Exactly. All right, so now what we're going to do is get the service for this thing. And we want to use real DNS here, okay? So what I'm going to do now is go to my DNS server here on Google Cloud. Now what we want to see, come on. All right, so we're going to deal with real networking DNS. This is not the smartest thing to do, okay? But we're going to do it anyway because we have to show that this works. So we have this IP address linked to this domain name. So what we're going to do is pull this up. All right, so make sure that that's our application, or at least one of them, kubectl get pods, PCRLL. All right, so that is real, okay? And you notice that we have this issuer is called the Shady CA. If you go to log into your bank and you see that, or a little red symbol, you should stop, okay? That will be bad. So now what we want to do is we want to give our users an interface that will allow them to request a real certificate from Let's Encrypt and also update the application automatically to consume that. So regardless if we have 3 or 5 copies, let's just bump this up a little bit, because the thing is we're not going to actually keep track of where these things are actually running. That's not important to us. We want the system to abstract that away. All right, so we'll bump the number, SF, deployments, TLS app, okay. So at this point, we can spin as many of these things up, and they will all refer to the same set of certificates, okay? So now they're all running. So now what we want, now these are up, is we have the certificate manager now. So as a user, before I go and build that Jira interface for people, I want to give them an easy way to express that they would like a certificate. So this object is enough for me to say, or express to the user, I would like a certificate for this domain. Let's Encrypt requires a little bit of data, and we also need to integrate with DNS, so we need to know what secret we should use to talk to our DNS provider. And this should, if this works, it should complete the puzzle and give us a certificate. So I'm going to remind everyone what that looks like. Here, our tool will sit here at the top. We're going to take one of those objects, and then we're going to communicate with Let's Encrypt and automatically give the application a new set of secrets. So let's see if this works. So as a user, we need to just create this object. So kubectl create-f certificates, hightowerlabs.com. And now our application jumps into action. It sees that the user would like a certificate. And if you do this behind something like Jira, they wouldn't even know that this tool is in place or that we're even using Kubernetes. So using this tool, we need to verify that we actually own the domain name. So Let's Encrypt will actually give us a token, and here's that token. And we put it here to prove that we actually own the domain. Now, if we own the domain and that checks out, we need to validate that our name servers are going to return the right token. So here I'm just doing a bit of validation. And once the validation comes back, we'll tell Let's Encrypt that it can verify that I own the domain, and it should issue us a TLS certificate. Now, while that's happening, kubectl git pods, we're going to watch the logs. So this is the code that we write, right? So we go to our apps, and we want to improve their operational behavior. So what we're going to do is watch the logs for the app we wrote. So we know our application comes up, and it loads TLS from file, TLS certificates from file. And what it will do now is register some hooks with the kernel that we want to watch whenever our certificates change. So I know the framework that I'm using will allow me to do it. I just have to write this bit of glue code. So it looks like we got our certificate. My tool found that the certificates in place are out of sync. You know, they're out of date. We're going to renew them and actually get one from the staging Let's Encrypt server. And what I would like my application to do is I want it to be a little bit more operationally smart about how it does things. No one needs to go around and figure out where these are running. You notice we're not talking about machines. We're not talking about nodes. The developer can just assume that we're going to have something managing the certificates in the background. All right, and if this works, at some point, this app should detect that there's new certificates, and it says it's done it. And all of them are doing this at the same time. So whether we had 1 million copies of this running, it should work. So if everything looks good, I hit refresh here, we should see a certificate from Let's Encrypt, and we do. So it all works, and when it comes to NoOps, I think no problem. Thank you. Hanging around, hallway track. No questions. How many people believe in this model? Yeah, I think it's totally the future of how we will have to work. A lot of this automated deployment stuff, we'll get to the point where the tools will just do the right thing. Developers will conform. The frameworks will get better. We're not going to be stuck in the manual deployment age for very long. And to add value, regardless of your title, developer, operations, you're going to have to get closer to the thing that people care about. That's probably the application. A lot of people are intimidated by that world, but to be honest, there's so much application code that operations people could write to make these applications perform better in systems like this. And there's other things that we would be doing on top of the application. So I think it's actually critical that we turn our bash scripting skills into the languages that were used to build our applications at our company and move some of that operational excellence into the application itself. And that way, all of these things become magical. And then I don't think anyone starts to do ops at that point. Everyone will just have this kind of transparent layer where it's just baked into what you do and to the systems that you use. All right? So since there's no questions,